So today we have an interview with a software engineer at Google. He's actually the brother to the first computer science professor who I ever had, and it was a really great conversation. I think I'm at an interesting crossroads right now between being early on in my software engineering journey so that I can still ask fresh and relatable questions to most people just starting out, but at the same time, I have my first internship under my belt. I have final rounds with Amazon and Capital One coming up. So I'm entrenched in the community and in the environment enough to ask pointed, substantial questions. We talked a lot about how to learn, how to code. We talked a lot about the changing landscape of education, how to pick a specific path in software engineering to go down, as well as just more broadly what did he think of Google and major tech companies with these so-called with the well, with the Fang obsessed kind of sub themes in a lot of Reddits and internet cultures related to software engineering. But yeah, I'm really just gonna let you get right into this interview. I think it was a great conversation, and I hope you enjoy. Don't forget to like, comment, and subscribe. Peace.
Yeah, my name's Marc Cohen. I'm a longtime software developer slash engineer. Um, I grew up in New Jersey, have been working for Google for the last 10 years, and I think I gave a talk at one of your classes at Seton Hall University, Alex, and thanks for inviting me. So happy to join you today and share anything I can to answer questions and whatnot.
Yeah, thank you. I really appreciate it. Yeah, you gave a talk in your brother's class, his computing for informatics class that I took that first semester, and that class actually, in like the first couple weeks of that class, I enjoyed it so much that I wound up teaching myself a bunch of programming on the side, which would eventually lead me to leave Seton Hall to pursue Rutgers for computer science for the different programs. So it's funny that the my favorite class from the first semester wound up getting me to leave Seton Hall. um, but yeah, just to update you on kind of what my path has been in the past 6 months or so since you really last got an update. I left Seton Hall after the fall semester, or really after the second day of the spring semester, and spent 4 or 5 months just teaching myself how to code pretty much full time, and led that and used that to get a software engineering internship at a local company doing a lot of back end work in C sharp, and some front end in React. And now I am going to Rutgers, starting my computer science journey there in the fall semester. I actually moved there on Friday, so this week has been a lot of me getting everything put together, but things are going well. And for next summer, I'm already interviewing for internships. I have a couple referrals to Datadog, to Facebook, to Stripe, and I'm interviewing with Amazon coming up. So things in next summer are looking pretty well. I'm looking forward to my classes, and yeah, this YouTube channel that I have is it's really to talk to people who kind of in a general sense don't necessarily get along with the education system, whether that be high school or academia. And then it does also kind of sub focus on my personal journey, which includes a lot of software engineering and computer science talk. So that's obviously what I want to talk to you about today, is your journey in software engineering and computer science, so that it might be able to give some of the viewers ideas for themselves, and just a little bit of guidance.
Cool. Let me ask you a question. You took time off. You left school, took time off to learn programming full time. Was that because you felt like you didn't have as much prep for computer science as you would have if you'd been starting from your beginning of university to where you were, and you kind of had to be in a little bit of catch up mode, or was there another reason?
Not necessarily. So, I feel like in order to answer that question well, I kind of have to give you my background to university. So, in high school, I graduated with an associate's degree. So, I already had 2 years of college credits by my senior year of high school. And transferring to Seton Hall, they had kind of told me that they were going to take all the credits and I would graduate in 2 years. And then once I got there, they were like, "Oh, by the way, we're not taking some of these credits. You're not going to graduate in 2 years." So there was that, as well as the Rutgers like top tier computer science program that really attracted me to make that transition. But the reason I took that time off was because I never actually wanted to go to college in the first place. When I first went to Seton Hall, it was kind of just because COVID was a thing and there wasn't really a better option. And at the time, I didn't want to go to university. I go to Seton Hall. I love my first semester. I love the classes I took. Great professors, great people, and it really showed me kind of like the virtue of higher education, of academia, and kind of where it might fit in my life and people's lives in general. If you go to my YouTube channel and you look back to my old videos, I just like decimate with numbers and statistics and personal feelings why I don't think college is necessarily the right option. And I've not necessarily retracted. I still hold a lot of the same qualms, but I do see college and academia's role in people's lives different than I did pre Seton Hall. So all this background kind of goes to the spring semester where on one hand, the classes I were taking was not going to transfer to Rutgers, so it didn't really make financial sense for me to take these classes that wouldn't transfer. And also, even though I had turned over a new leaf with regards to academia and higher education, I still really wanted to see if I could do it on my own. I still really wanted to see, and this was kind of my opportunity to fulfill older Alex Bianchi's dream of dropping out of college and teaching himself how to do something. And I did that successfully enough to wind up getting that internship and now starting to go to some of these interviews. And all my data structures and algorithms education has been entirely self-taught. I sat down with a textbook for a few weeks and just read it cover to cover about data structures and algorithms and used that to go into my interview prep. So it was part practicality, nothing was going to transfer, and also part I really wanted to prove to myself that I could teach myself these things. I did know how to learn, and that I could do it, and it's worked out. I am ecstatic about going to Rutgers. I'm really looking forward to my classes and to the journey that I'm going to go down getting my undergraduate degree, and it's they are taking all those college credits that Seton Hall didn't take. But yeah, so that's kind of the context to that spring semester and why I took it off.
Yeah. So you're sort of challenging yourself to say, can I do this on my own? And at the same time, I guess you're getting ready for school. And it's interesting because education is changing so much nowadays, not just with the pandemic, but there were trends already at work before the pandemic hit where I think people are questioning the value of traditional higher education a lot nowadays, especially in tech. There are these boot camps that you can take, and some people just take the boot camps and maybe change careers without ever having gotten a degree in computer science or even a tech degree. And yeah, it makes you kind of wonder, do you need to do all that stuff? It's very expensive to go to school and takes 4 years and all that stuff. And, it does seem like some of the rules are changing. I'm still a fan myself of higher education, but I think it's because to me, it's not just about the training and the preparation for a career, but it's also about the life experience and stuff like that. So I do feel bad for these young people now who are going to college and not getting to have as much of that life experience because of the pandemic. But hopefully that'll end soon.
Yeah, no, I totally agree. And kind of the conclusion that I wound up drawing was that there's a distinct difference between going to college because you don't know what you want to do and you just want the experience, in which case I feel like most people should probably either take a gap year or maybe look at community college, just anything that isn't $40,000 to $60,000 a year. And but also, if you have that direction, and if that direction requires a college degree, which I think some from and this is really more from like the research I've done perspective. I obviously don't match up to you in terms of experience. You've been in tech longer than I've been alive, but still some subfields of software engineering seem to require that sort of degree. I definitely see like a lot of people in artificial intelligence, machine learning, they say like, yeah, sure, go do your web development or your app development without your degree, good for you, but we still need our math PhDs over here. So it also depends what the ambition is. And there's someone I follow a lot online, and he talks about how you should probably be educated up onto how intelligent you are. So the smarter you are, and then there's this balance in my head that I'm still kind of wrangling of. On one side, the smarter you are, probably the more educated that you should seek to become. And on the other side, you can probably the smarter you are, the more likely it is that you can also teach yourself a lot of stuff, and you would be better off maybe starting a business or pursuing something more unique with that kind of intellectual creativity. So I have a lot of thoughts on all of that. I could talk about it all forever, but it's definitely interesting, and it's that was one of the questions I wanted to ask you was what were your thoughts on going to college to kind of expand on that. I just mentioned the PhDs in AI and ML. What do you think about graduate school? So kind of doubling down on education. Do you think that's an option that people should consider or pursue?
Yeah, I think it's so for the same reason you said, like it is useful to have a bachelor's degree because even though there are other paths into industry and you can get training in other ways, it still is kind of the gold standard when you apply for a job that employers expect you to have a bachelor's degree. From that point of view, it's really helpful to. It's not the only way in, but it's a huge advantage. And I would say a master's is even more so because sometimes you'll see bachelor degree required, master's degree is preferred or a plus. And so with the competition you'll face when you go out there in computing, anything you can do to get an extra advantage is great. And you might think I would then say PhD is even better, but I actually don't feel that way. And the reason is because in my experience, so I'm going way back now, because when I was in grad school, it was another era. But when I was in grad school in the sciences, including computer science, PhDs were very arduous and they were also very unpredictable. I had a lot of friends who would go for a PhD and nominally it was maybe supposed to be a 5-year program, but depending on how long it took you to get through certain milestones like your oral exams and your thesis and find a good rapport with an advisor and get the thesis in good enough shape to defend it. All of that stuff could easily take 6 years, even longer. I knew horror stories where people were sort of stuck and maybe it took them 7 years, or maybe they put all this time in and never finished. So long story short, I feel like a PhD is pretty significant investment, like the better part of a decade. And during all that time, you could be working and getting practical experience and making money and your salary going up and up and up. And so there are, so I guess my conclusion is that for me, a master's degree is a 1 or 2 year commitment. You're going to get some really good additional training and education, and it will give you an advantage in the workplace and getting a job. And so I think master's degrees are usually a pretty good deal, pretty good idea, not for everybody, but in general. A PhD, I'm just sort of the opposite. For most people, I would rather just go into the work environment and get some practical experience. But the exception to that is if you're really wanting to focus on something that's deeply technical or deeply on the cutting edge of computer science. If you're really there are people who want to just be machine learning practitioners and want to just apply it to solving interesting problems. And then there are people who want to push the envelope and develop the next algorithms. And if you're in that category, then a PhD makes sense, both so you can be competitive in that realm, but also you probably may want to be a pure researcher or a professor or something like that, where PhD is required.
Yeah, no, that totally makes sense. I just made a YouTube video. I released it last Friday, I believe, about this topic because I had been discussing it with some people that I met in the computer science space, students my age, and the conclusion we kind of all came to was if you want to do research and you really want to do research, you don't just kind of want to do research, then you kind of have to, and you're probably going to enjoy it in some masochistic way anyways. but if you don't, then there's a fruitful industry of high salaries that is probably a better option for you. So yeah, I
Mhm.
completely understand
Yeah.
everything you're saying.
And one little tip, I live in London, and so a little bit familiar with the European educational system. And PhD programs here are much more crisply defined in that, they take 4 or 5 years, and I think it's probably more like 4 years. They also have 1 year master's degrees here more commonly than they do in the US. And they're just more predictable. Like, you just kind of get through the program with a higher degree of confidence and less variability. So if any of your viewers or friends are interested in getting a PhD with the advantage of getting to live in a foreign country for a while and losing some of the risk of all that variance in the completion time, they should consider coming over here or going to a school somewhere in Europe.
Yeah, I've heard that too. Is interesting. I have a friend doing his undergraduate in I think Germany right now. But it's really interesting. It's definitely something that's worth looking into, and I should definitely do my research there. So I appreciate
Mhm.
I appreciate the tidbit. How is living in London? I know you grew up in America or in New Jersey. What brought that move? Was it Google? Was it an offer from them? Or what? Why?
Um, I was always interested. My wife and I had kind of wanted to live in Europe for a while. We did live once in Belgium for 6 months, and that kind of whetted our appetite to do more travel and to try to live in another country. When you grow up in America, it's such a big country, and it's such a sort of dominant country where everyone speaks the same language and everyone shares the same culture, that it's almost it just seems natural to just kind of stay there. And like, the big move might be to go from New Jersey to California or something like that. And it's just not as natural to strike out and live in another part of the world outside the US. And I felt like that can be a really rich opportunity and rich experience. The other thing was, our daughter was just starting high school. And so we thought, it's kind of like now or never, because by the time as far as exposing her to another country, once she gets really embedded in high school, we didn't want to, like, pull her out of it. So we thought maybe this is a good time for all of us to try living overseas. And so I just put in a request with my management, and they said no. But a few months later, actually, just by coincidence, an opportunity came up for a manager. At the time, I was a manager myself, and they needed a manager to build a team in London. And so they came back to me. And so the lesson there that I took away from that experience was, if you're thinking about something and you're not sure, but you really would like to maybe try something, don't, feel be free to ask people. Don't worry that someone's going to say no, because that's not going to be terrible, but at least it plants a seed in people's head that you're interested in doing something. So
Yeah,
they
that
they
totally
got
makes
back
sense.
to
That's
me.
really interesting. My family is from Argentina, so I've made some routine trips down there. Not since the pandemic, sadly, but
Mhm.
I love it down there, and I plan on, as soon as I get my bachelor's, or maybe before, however the timeline works out, before I start my life in the real world, I would like to spend preferably 6 ± 6 months down there. And just, I have family up and down Argentina, so I could
Mhm.
backpack the country and always have a place to stay no matter where I wound up.
That's awesome.
Yeah. So as far as, we a lot of life talk, a lot of academia talk. As far as your role at Google, and just software engineering in general, what do you do? How did you get there? And I know you're in more of maybe a managerial position now, but when you were doing the more of the engineering stuff, what did you work on?
Mhm. So at Google, I've always been involved in an organization called DevRel, or Developer Relations. And so this team is really focused on helping people outside of Google take advantage of our technology. So there are developer relations people in Google Maps, in Android, in cloud, Chrome web developers. And really the role is to help people take advantage of the technology from a developer standpoint. So not a consumer who wants to like use Google Docs or Gmail or search. It's more for people who are trying to build applications that use Google technology. And a lot of people don't even realize that that's a thing because they think of Google from a consumer standpoint, which, you know, there's billions of us that use Google every day. But there are also people who build applications on top of Google. And the part that I focus on is Google Cloud. So if you have a company and you want to build a software system, like let's say, you know, imagine Airbnb. They need a website and they need a whole bunch of computers and they need a whole bunch of databases to store all this information. And the old-fashioned way to launch a business like that was to go buy a million computers and run all your web stuff and your database and all that stuff on these computers. And Google Cloud basically lets you rent all that equipment and just as much as you need. And if you need a whole lot more, you can just kind of turn a dial and all of a sudden you go from 100 to 1,000 processors. And if business gets slow, you know, something bad happens and your demand is going down, you turn the dial back the other way and you pay for a lot less and you use a lot less. So my job in a nutshell is to help professional developers and companies understand how best to take advantage of all of that, all the cloud capabilities, we call it.
Awesome. Yeah, that makes a lot of sense. That's pretty cool. So I know we were talking about the university system. You did get your master's in computer science long ago now. But would you say that kind of education that you received in the master's program, does it linger to this day, or was it more maybe in the 10 years after college? Yeah, but at this point everything is kind of evened out in the wash.
Yeah, I don't know how unique or common my experience was, but actually the stuff I learned in my master's degree, I still use, which
And
amazes me. So I got a bachelor's degree at Rutgers and in math, but I took a lot of computer science courses because I was quite interested in programming. I didn't end up using very much of the math that I studied. The the computing, I still like, you know, that's down there somewhere. It was basic stuff like algorithms, and you know, I remember learning different search algorithms and stuff like that. So that's all down there somewhere, and that helped me understand how to get started in the industry. But then when I went off to my master's degree, I went to Cornell in 82, 83. And that was right around the time when Unix had come around. So the bulk of the industry was still built on kind of old-fashioned, old-school mainframe computers, mostly IBM, but there were a few other vendors. But typically, you would have a computer and you would get the operating system with the computer. The company that sold you the computer would sell you the whole software stack with it. So you're using an IBM mainframe, you're using IBM's assembly language, you're using IBM's operations software and everything. And a few years before I got out of school, before I got out of undergrad, Unix popped up at Bell Labs, and it was really revolutionary because it was the first portable operating system where you could run it on any computer, and it sort of like drew a line between the hardware and the software. In addition, it like introduced a ton of really visionary capabilities, like the the interactive shell to run commands, which seems just trivially obvious, was a new thing for that operating system. Treating everything as a file, like the network device could be conceptualized as a file. Just about the keyboard, every I/O device on the computer could be operated through a file. So there's all these innovations, and when I got to Cornell, I took a class on system programming, and I learned Unix and the C language, which was a C programming language, is another thing I could go off on, but it's been around for 50 years, and it's still one of the top 3 or 5 most commonly used programming languages in the world. And like, I got hit with Unix and C at the same time when I started my master's degree, and it was just like life changing. It was so valuable. You want me to pause for a sec? Or- it's no problem. I can just keep going through, but I didn't know if you wanted to pause on. Okay. So I took this course, and actually I have, if I can find it. Here it is. I have this Bell System Technical Journal, which was published in 1978. And in this is like to me the Bible, because in this book is every technical paper that it was a special edition of the Bell System Technical Journal was just a technical journal published by the Bell System, AT&T. But this was a special edition devoted to the Unix operating system. It was introducing Unix to the world. And so like there's articles about the shell, the C programming language, the implementation of the operating system, and the class was basically digging through all these papers and just learning the guts of the operating system. And
That's
the funny
great.
thing about it was it's 2021 and I'm still doing shell programming. I'm still writing. I don't always use C that much, but occasionally I do. And like a lot of the tricks and tools and commands that I learned then, I'm still using today. And the other thing is just like the whole, they're like GUI people or interactive drag and drop mouse type people and command line people. And I do a little bit of both, but I'm at heart a command line person. And I think that's where I got it from. So yes, the long answer to say that stuff from my master's degree really stuck with me a long time.
That's really that's actually very cool that that like you were right there when Unix came out. That's crazy. First layer of abstraction, I guess.
Yeah.
First
Yeah.
true
And
layer
then
of
Linux, of
abstraction.
course, took that stuff to an even greater height. But a lot of Linux was really directly inspired by Unix. So you sort of can see the lineage going back.
Did you understand at the time how big Unix was gonna be, or were you like, oh, this is cool new tech, I'm gonna take this class?
It had been out for a few years, and so it had made it into universities. Berkeley, UC Berkeley in particular, was famous for taking Unix from Bell Labs and building their own sort of. It's like what we call a distribution in the Linux world, which was called Berkeley Unix, and so it had already started getting popular amongst the computer science tech elite, right? You were hearing more and more about it, reading more about it. There were people were starting to publish magazines about Unix, and so I did have a hint that it was going to be a big thing. I didn't realize how big it was going to be, but the real reason I engaged with it so much is it just felt so right to me. Like I'd been using IBM mainframes in my first summer before I went to. I got hired before my master's, and then I went away to school as part of the job. So it was kind of a weird situation. But in the summer before I left for Cornell, they had me doing IBM assembly language programming on this MVS system. It was called, and it was just so wrong in so many ways. Like it was just so painful and so. I mean, at the time, you don't realize it until you see the alternative. And then I went to Cornell and I was introduced to Unix, and I was like, that's what the way computing should be. And it was just so right to me that I almost didn't care if it was going to be successful or not. I wanted to use it. It's one of those things where if you find something compelling enough, you just want to keep learning about it and working on it. And that was kind of where I was. And I did think it was going to succeed, but I had no idea how much. I was surprised, like everybody else.
Yeah, yeah, that's again again very cool. Yeah, so you worked at Bell Labs. I see that on your LinkedIn here, which is like I hear now. I know Bell Labs as Bell Works, the place that my family caters some events every once in a while because now it's an office building and my family owns a restaurant and a catering facility. But once I started getting into computer science and I would listen to these podcasts and these professors would be like, oh, back in the day of Bell Labs. And I now find that kind of history of just the building, which I just know as a building, very very interesting. So it's really cool that you were right there.
Yeah, that was a really fun place to work. In many ways, it was, I think of it as the Google of the 80s. Well, for quite a while, it was the preeminent, engineering company in the world, really. Came up with all these, core innovations that have revolutionized science and technology. Like the transistor was invented there. They kind of got a Nobel Prize for proving the existence of the background radiation from the Big Bang. Um, the, all kinds of algorithms and, Unix and C, obviously. Information theory was born there. So all kinds of amazing things came out of Bell Labs. There's a really good book about the history of Bell Labs if anyone's interested. But yeah, when I got there, it was like Google in the sense that it was very sort of unusual. It had a culture where everybody cared about science and data, and it was sort of almost like being at a university. I just remember things were unconventional. People would work weird hours. People would dress, you know, not in a not normal way for an average business in the 70s or 80s. People were t-shirt. It was really like being at a college, and it just felt really relaxed and a place where the technology and the understanding was what mattered the most. And it was very much also a flat hierarchy, just like Google is, relatively flat. Um, and it was a place that was based on sort of a meritocracy. Like the ideas that you had and the accomplishments were what drove things more than like who you knew and politics and stuff like that. I mean, it wasn't perfect, and Google isn't either, but it was a nice place to work.
Awesome. Yeah, very very interesting to hear. I'll have to get that book from you. So kind of fast forwarding a little bit to Google, I do want to talk a little bit about big tech because in computer science, kind of, I guess in the computer science part of universities, all the students are obsessed with getting into however they dub it, FANG, Big N. There's a million different ways that they name it. Do you think that the obsession there is kind of justified in the way that these companies are the best? They do have the most opportunity, they pay the most, and you're kind of justified for wanting to pursue them? Or is there like a more open-minded approach that students might be inclined to take towards what company they seek employment from post graduation?
Yeah, I mean, I think the mystique is a little bit exaggerated because when Google was a company of 20,000 people, it was really getting into that company was going to change your life. Not only because you were building something that was just revolutionizing the world, but if you got into the company at that point in time, you were going to make a life changing amount of money. And you were going to just work on something unbelievable, like a once in a lifetime opportunity from an engineering challenge perspective. But Google now has, I don't know exactly, 125,000 people, and it's hard to be that kind of unicorn when you're that big. And I think they do a pretty good job of preserving a lot of the elements of their essential culture, but I think they also have had to make some sacrifices, and it's not quite as unique and special as it once was. That said, it's a great place to work. I really like the culture in general. In most cases, um, the pay is good and all that stuff, but that could be said about a lot of companies now. And so I don't. I think people maybe overemphasize the big five or the big four or whatever. I think you'd be better off thinking about what kind of work you want to do, and then having a little bit of a broader target. The other thing is, it's really hard to get hired at Google and Facebook and a few similar companies. And part of the problem is that they over engineer their process to minimize false positives. So they really go out of their way to make sure that for every person that they hire, there could be 5 people that I'm making this number up. There could be 5 people that should have been hired that they don't hire because they're really afraid of hiring someone who's not appropriate. So much so that they'd rather err on that side than hire one person who wouldn't be a good employee. So it's hard to get hired in these companies. And one strategy, and so I don't discourage anybody from trying for the best job they can get, but one strategy to think about is build up some experience with another company where you can really show what you're good at and what you like to do. And then you'll have an even stronger case if you don't get the job you wanted right out of college. So
Yeah,
take it
no,
in.
fair enough. That's definitely a very valid way to look at everything. I appreciate that perspective. I think internships are an interesting case because some of that over engineering to avoid the false positives isn't there as much because it's only 2-3 months. So the
Yeah.
process from where I've been has been very standardized with all the companies I've been dealing with, and it's been I apply, I get an email back, I wait maybe a few days, few hours, few minutes depending on the system. I get an online app. I got an online assessment, which is just some data structures and algorithms question. And then for Amazon, it was that, and then the final round interview. And I think for Facebook, it's that, and then a phone screening, and then a final round interview. So there's no like four interviews one day with four interviews, and it just in that day alone. So the process is definitely slimmed down, and I think that's a unique opportunity for kids to kind of get their foot in the door while they still can. So that's
Yeah.
my game
So,
plan right now.
yeah,
That's
there's
what
a
I'm
lot
currently
less risk,
focusing on.
much less risk associated with hiring an intern. And so you're right. I think the the hurdles that you have to jump over are fewer. And I agree. I think an internship is a great way to get experience and also get something to add on your resume.
So the thing that I messaged you about, what that eventually led to this call, was finding your niche in tech. So in the last few minutes here, if you wanna talk to students now who maybe they don't know exactly what they want to do, but they have a list. They have a few things they're interested in, and maybe they have some projects in a couple of topics, no projects in the other. What advice do you have to kids to find that niche? Because especially with what you just mentioned, with find a company that you can show what you're good at. For a lot of kids, they're like, yeah, that sounds great. I don't know what I want to be good at because I know I can be good at pretty much anything I put my mind towards, but I just don't know
Mhm.
what I want to be good at. So what do you think about that conundrum that a lot of kids face?
Yeah, it's funny because my daughter went to university here in Europe, in Scotland. And the system here in Europe is such that when you apply to college, you have to know what you're going to major in. And so I'm used to the US where you go to college and you don't declare your major for, I don't know, a year or two. And you get that first year or so where you can just try things and experiment because a lot of 18-year-olds don't know what they want to do with the rest of their life. That's totally normal to me. And so I sympathize with people who say, I don't know what I want to do yet. I don't know what to specialize in. And my advice would be just try as many things as you can and do your homework and try to find out what the options are. For example, you know, for Google, most people think, and all the other companies you were talking about, I think most people, when you ask them, like, what's a tech job at Google, most people think a software engineer, which is probably the biggest category. But there's all these other jobs like, product manager, hardware engineer, and there's also some less technical ones like system administrator. I'm looking at my list here because I actually had this queued up to prepare for this question. Business analyst, application engineer, program manager, which is a person who kind of coordinates development projects. And so in that role, you're not actually, you don't need to know or care about technical details. You just have to be good at organizing and helping people work through all the details of a project. There are tech writers who, if you're good at writing, um, you can apply those skills in the tech field and make really good money and have a really fun job. So my message is there are all these possible ways into the tech, quote unquote, tech domain. And it's worth finding out about all these different types of careers because you never know which of them you might be well suited for, and it might open up a whole new door for you. And then in university as well, just try things. Be open to classes. A lot of people sort of get turned off on math, for example, because they say I'm not a math person because they had a bad experience with math early on. And put that aside, try math again, because maybe you'll find a professor or a teacher who can make you understand it in a different way. So yeah, just be open to trying new things and seeing if something clicks for you. And if you don't find the perfect thing, just pick the one that's best, but keep exploring. One other thing I want to say is there is just an incredible amount of online educational opportunities right now between YouTube and Coursera and Berkeley and MIT and similar universities have all their content online. So you can learn, just as because you did this, you can learn just about anything nowadays. So it's the granularity of like trying something when you're in university by signing up for a course is pretty high. Like you're devoting a lot of time and money and effort if you try something by taking a whole semester course. So an even better strategy is like, I might be interested in, I'll say tech writing again, but I'm not sure if it's for me. You don't have to sign up for a whole course. Just find something online, some resource online, find out about it. And by the way, I have a list of videos which I keep, which are like a day in the life of an X, where X is all these different jobs at Google. And I'll share this with you. You can put it in your description if you like. And people can click through and then see like a nice short video about what it's like to do that job in a company. So yeah, be open to trying things. Try to focus on one broad area that interests you, but be okay with moving around to something else if it doesn't work.
Yeah, of course. It's all great advice. There's this balance that I've thought about a lot between breadth and depth. You can try everything, but if you only try it at the surface level, then how much did you really try? Like, how valid was that attempt to try it? So I think that's where classes really come in for me. Is it's like, okay, I've gotten like a broad understanding of this thing. Now I want to go a little bit deeper and really understand this given topic. So that's when I'm gonna be like, okay, what classes does my university have on this particular subject? With me, I'm in a unique situation with my next semester because I technically still have to take CS 111, like their 101 course, because computing for informatics didn't transfer as that, and I've never taken CS 101 before, so coming off of the software engineering internship, that might be a little bit of an easy class for me, but I do get to take a bunch of math courses, so I've kind of looked to that as an opportunity that I can take. I'm taking linear algebra, Calc 3, honors physics, and then hopefully in the spring semester, a introduction to mathematical reasoning, which is like a really heavy stats class and ties in with a lot of the math related to machine learning, and as well as a mathematical reasoning class, or not mathematical reasoning, it's a discrete structures class that ties into a lot of the proofs behind algorithms. So I don't necessarily get to take all the fun computer science electives while I'm getting my core out of the way, but I do get to take a lot of these computer science adjacent math classes that I think will help me kind of get a deeper understanding and appreciation for all the stuff that's going on.
Yeah, definitely. I used to say that I've never used calculus. I mean, I liked it. I liked learning about it, but I never used it until recently. So oddly enough, like 40 years after I graduated, I all of a sudden needed to use a lot more math. Why is that? Because of the machine learning revolution. Machine learning and AI are all based on mathematical optimization. So defining functions, finding the derivatives of those functions, and trying to find the global minimum of those functions, where the function is a loss function. So it's how far away are you guessing from the ground truth, and then you try to minimize that loss function. And so all of a sudden, stuff like linear algebra and calculus became much more important to my career than it ever has been in the past. And I think when I say that, some people might go, oh no, I have to actually be great at calculus. And the key is, you don't actually have to use calculus, because you really won't typically end up differentiating a loss function by hand or even using software, because you'll use a package like PyTorch or TensorFlow, which will do all that work for you. But if you have kind of an understanding of what differentiation is, and how you're kind of like, you find the minimum of a curve by taking the slope of the curve and working until it gets to zero, so it's horizontal. If you just kind of understand some of the concepts of calculus, it will help you immensely in this day and age. The other thing I totally tangent from that, but that I like to say, is that and actually, there's a TED talk about this, which is that, like, when you're learning math in high school and in college, I think the pinnacle, what's seen as the top of the tree or the pyramid, is calculus. But really, the more important subject, the one that everybody should learn, is statistics and probability, because those have much more practical application to our daily lives, and they're much more widespread. Like, the problems you can solve with statistics are just everywhere. And so that also applies to computing. If you end up going into computing and you have to do something in data science or something in machine learning, statistics and probability are like just absolutely critical tools to thinking. So yeah, I think I forgot where we started with this question. I was trying to like
I
come
told
back.
you about I told you about the math classes I was taking, and then you gave me your comment. But no, that's great. That makes a lot of sense.
Yeah,
That's
I think I was going with it's good to learn math.
yes.
It was always good to learn math, but now it's become more practical due to the fact that a lot of common current computing stuff, especially AI, is based more firmly on mathematics.
Awesome. Yeah, no, that's great. We 5 minutes left on the time that we agreed on, so I want to respect. I'm assuming you're a busy man, but do you have any closing thoughts? Any questions that maybe you wanted me to ask that I didn't ask? Anything at all?
Um, Let me just see if I had anything here. I did have some notes. Yeah, I would say that sometimes I'm asked for sort of general advice for tech, and there are a few things I like to talk about. One is, I really encourage people to learn by doing. So if you want to learn a programming language, for example, instead of just picking up a book and trying to learn C++ or Java or Python without a specific end goal in mind, it's very hard to stay focused and to keep going. We've all had that experience. We get through chapter one and we're really excited about what we're learning, but then we don't kind of keep it up. And instead, what I recommend is you pick a project, something you want to accomplish. It doesn't have to be huge, but pick something you want to do with the language, and then use that as your vehicle to learn. And I think that will keep you motivated longer. Find a mentor. One way to do that, that sounds easy to say and hard to do, but one way to do that is go to meetups in an area that you're interested in and just talk to people, and try not to be inhibited and afraid to talk to people, because most people want to help other people. And if you get them talking, you will learn from them. Keep track of what you do. So like, if you want to get into computing, for example, get a GitHub account and put some code up there. It doesn't have to be like the most amazing thing in history. Just get some projects where you played around with something, and then when you interview, you can link to the GitHub repo on your website or on your CV, and it'll just be like, okay, this person actually has done something with machine learning, because I'm seeing them experiment with some code here. And make a plan. This is like the most trivial sounding thing, but a lot of people don't actually write down what they want to do and how they want to get there. And sometimes just having a plan is the simplest thing, and yet the thing that will make you get you going and help you kind of get off the starting block. Those
Yeah.
are my
Hmm.
ba- basic tips, I guess. Those are my tips, I guess.
Well, they're all great tips. I'm an advocate for planning. A lot of people don't have a plan, and like I have two sisters, both younger, and I tell them both, like, even if you don't know what you want to do, this is more applicable to my youngest sister who's starting college as a freshman,
Mhm.
and it's like, I understand you have no idea what you want to do, but just pick a direction and just go there, and along the way you'll figure out what you actually want to do, or maybe that is what you want to do, and fantastic. But just pick a direction, try stuff, do all that, but pick a direction, pick a plan, and execute on it, and that'll just pay off in spades. But
Yeah,
yeah, thank you so much. I'm gonna stop the recording now. I normally do. I can be a little choppy with the intro outro because I'll record
that's
myself
okay.
the everything.
That's okay.
Um,
No problem.